In this video, we are going to take these graphs and we're going to write trigonometric functions to match them. So for number 19, we are going to write a secant function that matches this graph. Now, secant is the reciprocal of cosine. Alright, that's important because normally when we graph secant, the first thing we do is we graph the cosine function and then we go off of that. So we're going to use that and actually sketch a cosine function first. And then based on that, we should be able to write the secant equation that matches it. So the midline. I'm looking at the tops of these branches and the bottoms of these branches. And I see that I've got -3 and +3, which makes it easy because that means the midline is going to actually be the x-axis for this particular problem. Alright, so there will be no k value. There will be nothing added or subtracted on the end. Okay, what else? What else? Phase shift. Okay, look, so I know that my cosine function is going to intersect with my secant function at these highs and lows. So when I draw my cosine function, it's going to touch at these places. Okay, so based on the 3 points that I just gained, I'm going to go ahead and look at this as the beginning and the end of one period of the cosine function. Alright, because here's where, if this is the beginning, and then here I've reached that same point again, that's going to be one period. Okay, so that tells me a couple of things. Well, look, before I get carried away, let's get the vertical asymptotes going. Let's see, just halfway in between these points, it seems to be that we have a vertical asymptote going right here, just using the symmetry of it all. Okay, that's close over here. Okay, now let's look. From this vertical asymptote, this point is 3 to the left, and this point is 3 to the right, so this should be good. And let's do the same thing here. If it looks like this will be where the vertical asymptote is here at pi. Okay, and again, it's 3 away and 3 away. So these are going to be my asymptotes. Okay, now I know that my cosine function will touch these asymptotes at the midline. Whenever we draw these graphs ourselves, we have the midline, and then we have our cosine function, and then we say, oh, wherever the cosine function touches the midline, there should be asymptotes there. Well, now we're working backwards. So here's the midline, here's the asymptote. That must be one of the places where the cosine function passes through. Okay, so here we are at the midline and the intersection with the vertical asymptote. So these are my 5 critical points for my cosine function. So I could sketch it. Alright, so my cosine function is looking like this. Okay, it's a little bit tough to sketch because it's very tall, but I'm doing it, man. I'm doing it as best I can. Okay, so here's a sketch of my cosine function, one period of my cosine function. So that is going to help me to write my equation. So there's a couple things I need. First of all, my a value. You know what, I'm just going to keep it pink. Or red, whatever you want to call it. So the a value. So the a value is going to come from the amplitude of my cosine function. See how it is going up 3 and is going down 3. So the amplitude is 3. However, see how this is an upside down cosine function? looking at this period, it's upside down. So that means that my a value is going to be a -3. So I'm going to say -3 secant. Okay, and then whatever happens next. So I need the b value next, is going to be inside of the parentheses, will be the b value. I know that the period is going to equal the normal period divided by the b value. All right, that's something that we know. But so I need to know what the period is, I guess. We haven't really figured that out yet. So if I want to know the period, I will look at the beginning and the end, and I will subtract those two. So if I do 7 pi over 4 minus -5 pi over 4, that should give me the period. Okay, in fact, let me just start over. Okay, so the period is going to be, all right, the high value minus the lower value. So if I do 7 pi over 4 minus -5 pi over 4, that should give me the period. Now, when you subtract a negative value like this, you add. So this is 7 pi over 4 plus 5 pi over 4. Okay, so that means that the period is 12 pi over 4, which means that the period is 3 pi. So that's good to know. I know that the period is 3 pi. But what I really need is the b value. So the period is going to equal the normal period divided by the b value. But we now know that the period is 3 pi, so that's 3 pi is equal to 2 pi divided by the b value. If I swap these, which I may, that's going to give me that the b value is 2 pi divided by 3 pi. So that tells me that the b value is 2/3, because the pi's cancel out. So the b value goes right here. So I'm going to have 2/3 right here. Next comes the phase shift. Well, guess what? The phase shift is just going to be the beginning of the period. So looking at the cosine that I drew, see where I put the first point is at -5 pi over 4. So that's the phase shift. So that means in the equation there's going to be a sign change, and I'm going to put plus 5 pi over 4. Like that. And I'm out of room. Luckily there's no k value that I need to add, because the midline is the x-axis. If the midline was anywhere else, I would have had to add something on. Anyway, that is a perfect equation, a secant equation for the graph given. That is how you do that. Okay, so that was number 19. Last one, number 20. We're going to do the same thing, but this time we just want a sine function. So this actually should be simpler. So we need the midline before we get too carried away. Where's the midline going to be? Well, this has a height of 5 and it has a low of -3. Okay, so this is a high here at 5 and a low of -3. If it's 5 up and 3 down, can you see that that is a total of 8? Okay, from here to here is a total of 8. That means 4 is the amplitude. It should be 4 up and 4 down from the midline. So imagine that this was the midline here at +1. Okay, that's my hypothesis. If this is the midline, then would the highs be 4 up and would the lows be 4 down? So here I go, 1, 2, 3, 4. And going down, 1, 2, 3, 4. So it makes sense that +1 would be the midline. Okay? And there I just mentioned the amplitude, didn't I? So it's the total from top to bottom, the total range is 8. Then the amplitude is going to be 4 4, of course. Okay, from the midline to the top, okay, they're 4 apart. Okay, now I have a choice as to where I want to think of this graph as starting. And so I'm going to have more than one equation. If I think of the graph as starting here at negative pi over 4, then this is going to be a positive sine function. All right, if I look at this as one period of my function that's going like this, whoa, what got a little crazy there in the middle. If I look at it as beginning and ending here, here's one period of the sine function. That is a positive version. See how the way it goes up first? So one version of my equation would be like this. The amplitude is 4, and I'm going to go ahead and say positive 4. Almost forgot to write sine in there. Alright, so positive 4 sine. Okay, next I need the b value. So I need to do the same thing I did before with my previous function. I need to look at the beginning and the end. Okay, so I have negative 4 pi and I have positive 2 pi. So the period is going to be what I get if I subtract those. Okay, I feel like I should put a line right here to separate this. So the period is going to be the end value minus the beginning. So minus negative 4 pi. And here again, when you subtract a negative number, you add. So this will be 2 pi plus 4 pi. So the period is 6 pi. But what I need is the b value. So I know that the period is going to be the normal period divided by the b value. But now I know that the period is 6 pi. So that means 6 pi is going to equal 2 pi over this b value. If I swap these out, that tells me that the b value is 2 pi divided by 6 pi. And the pi's cancel out. And 2 over 6 reduces to 1/3. So the b value is 1/3. So that's why I'm going to have a 1/3 right here. Okay, now the phase shift comes next. Now, if I look at the graph as starting right here, then this is my phase shift, negative 4 pi. So here comes a sign change, positive 4 pi. Okay, now on the end, I need the number representing the midline, which is 1. So I'm going to go ahead and put a k value, a plus 1 on the end. So this would be a perfectly good equation for this graph shown. Now, I chose to start my sine function here. Now, if I pick a different starting point, that's going to change some things and not others. It's not going to change the amplitude, and it's not going to change the period. So the 4 and the 1/3 will not change. It's not going to change the midline. There are two things that can change. The phase shift, all right, because my phase shift of negative 4 pi I saw because that's where I started. And it also could change the sign of my a value. This could be a negative 4 if I pick a different starting point. So imagine that instead of starting here, imagine that I look at my function as starting here and ending here. So now one period of this sine function is going to look like this. Okay, this is still one period of a sine function. It's just a sine function that goes down first. Okay, so I'm going to erase some of this great work that I just did. You know what, maybe I'll squeeze it in above, just so I don't have to erase my work. Okay, so here's another version of the function, y equals. In this version, the function is upside down, so I'm going to put negative for sine. Okay, the b value is not changing because the period is not changing. What is changing is the phase shift. So now, instead of starting at negative 4 pi, I'm now starting at negative pi. So that is going to be my phase shift. So in the equation, there's going to be a sign change, and I'm going to put x plus pi. All right, my midline is still at 1, so I would still put a plus 1. So there is another equation. Now there are other equations that I could make, but those are the only two where you could fit a full period in the image. So probably you did one of these if you did this on your own. And that is going to do it for this video. I hope it was helpful, and I hope to see you on the next video.